All right, so this is your warm-up. This is in Journal 13. These are the most missed questions from your benchmark test. So let's take a look at the first one. I'm going to let you work on it in groups. You can work on the boards. You can work in your journal. See what you can do with it. Okay, so remind me one more time. What's my motto? Factor, cancel, smush. That's for multiplication. And how do we divide? We don't divide. We multiply by the reciprocal. Okay? We don't divide. We multiply by the reciprocal. So, which ones are equivalent to 4x divided by 3 times quantity of x minus 4? The first and the last. Are there any questions on the first and the last? Again, if you have questions, make sure you can get these to work out to be what you want them to be. But if you have questions and you don't understand why, you're more than welcome. I worked it out on my table during second block, so you're more than welcome to go back to my table and kind of peek. Was that helpful for those that did? Okay, and kind of look at the work. So make sure you get that in your journal. My question to you is, how many got it today? So my question is, why didn't we get it the other day? Okay. The reciprocal, gotcha. Okay, so we forgot to multiply by the reciprocal? Oh, no, go ahead. What else? 2 answers. That's what second block said. They said they only picked one. So make sure you read the directions. Anything that has a gray bar at the top means it's going to be a technology enhanced item. So make sure you choose more, all that apply. Sometimes it might be one, but it could be 2, it could be 3, it could be 4. Any other thoughts as to why we missed this? Yep. Couldn't remember how to. Do we know how to do it today? Is my question. Okay. All right. So the second most missed question looks like this. This is still in your journal. Okay. Looks like this. So why don't I give you a second to look at it, and then we'll talk about what it is. Let me ask you this. Yeah, I would write them all down because we're going to talk the others that aren't symmetric property. They are other properties. So we're going to kind of review symmetric along with a couple others today. Anybody can explain to me what the symmetric property is? Go ahead. That would work too. It doesn't matter. Here's the thing. I love to use my 8th graders as an example on this, but when I taught you guys in 8th grade, I always put this equation up. 3 equals 2x plus 8. Now, we think that's an easy peasy equation right now. But when you came in as 8th graders, y'all said, oh my gosh, Miss Corns, I don't like that equation. Do you know why younger students would not like this equation? Because the x is on the right side. And in elementary school, everything has the variable on the left side for the most part. Okay, you feel more. How many still feel more comfortable when your variable's on the left side versus the right side? Anybody still feel a little more? I mean, you can deal with it on either side, but some of us still prefer it to look like that. That's what the symmetric property says. It says what's on either side of the equals. If you wanted to, you could take it and flip-flop it to the other side. Okay, we call that flipping our seesaws. Okay, you can flip it to the other side. So take a minute, talk in your groups, and see which ones you think would be the symmetric property. And if they're not the symmetric property, what property are they? So talk about that in your groups. All right, so let's take a look at these. Let's look at the first one. 6 minus 5i equals p minus 2. And p minus 2 is equal to 8. So then who else is equal? If these are both equal to p minus 2, who else is equal? 6 minus 5i is equal to the 8. What property would that be? This is the transitive property. If A is equal to B and B, notice they're the same, is equal to C. If these guys are both equal to each other, you can take the middleman out and connect A to C. The first part is 6 minus 5, that was your A, and 8 was your C. So that would be transitive. Does that make sense? Because I'm not replacing something with equal value. I'm just connecting, if these two parts are equal and these two parts are equal, by process of elimination, we know that the first and the third part are also equal. Okay. So how about the second one? It is substitution. 8i plus 6i, all you're doing is replacing it with something of equal value, so that would be substitution. Okay. How about the third one? 3i equals 7 plus I, and 7 plus I is equal to x. Then we know that 3i is equal to x. What would that be? Transitive. All right. So how about the fourth one? 3i plus 7i equals y. So y is equal to 3i plus 7i. Is that symmetric? Yes. You've just taken what's on either side of the equals and flipped it around. Okay. 4 times quantity of 8 plus 2i equals 9. Then 9 is equal to 4 times quantity of 8 plus 2i. Which property? That is your symmetric. So it should have been the bottom two. Okay. Any questions on why we missed it other than the fact that we just need to review our properties? Agreed. We just need to go over them and refresh them. So, any questions about these? All right. Well, let's get into today's lesson. We are going to recognize parent functions today, and we are also going to apply transformations. And instead of me getting up here and just giving you all the parent functions and showing you what to do for the transformations, this is going to be like a little investigative lesson where I'm going to let you figure out what the parent functions look like and what happens when we apply transformations. So I'm going to give you all a piece of graph paper. Okay, so everybody got a piece of graph paper? All right, so here's what we're going to do. In groups, I want you to use a table of values and graph the following equations. Okay, so you're going to graph these following equations. And I've given you a suggested table of values. Why would I suggest going from -2 to 2 on the x's? Well, I agree. That's 5 points, so that's going to give you, only if you only did 2 points, that would only give you what shape? a line, right? So, because these aren't just going to be lines, they might be curves. So you need more than just 2 points. So you need at least 5. Why would I want some negatives and some positives? If I'm going to take a picture, would I want to only see half of the graph, or would I want to see the whole graph? It's like some on both sides of the axis. Does that make sense? So I want to see the whole picture. Now, -2 and -1 aren't going to work for all the graphs. So this is a suggested table of values. Okay, it's a suggested. So you can use any values you want to. You may also use your calculator to also assist you. But I want you to take these 6 functions and I want you to plot them. And once you plot them and draw them, I want you to raise your hand and call it. I want to see them up on the board. Okay, so somebody say, I'll take number 1, I'll take number 2, I'll take number 3, and we'll get them up on the board and look at them. Any questions on what you're doing? Okay, ready, set, go. Okay, so let's take a look at these. Okay, let's take a look at these. So, number 1, y equals x. If you graph it, what will it look like? I think it's up there in purple on the board. There's the table of values that goes with it. It's going to be a linear line. And again, we've looked at linear lines, but these are the parent functions that you are graphing right now. And everybody says, what's a parent function? A parent function is the most basic form of the function. Does that make sense? We have not done anything to the x, because the minute we start to, like, what if we said x plus 4? What will happen? It might shift up, or it might shift down. Or if we put a negative in front of the x, what's going to happen? It's going to reflect it and make it go the opposite direction. You can take graphs and you can change the slope. You can take that line that you have right now and you can stretch it vertically, which makes it go like this. You increase the slope on it. Or you can compress it vertically, which would make it flat. You can take it and move it around. Does that make sense? You can flip it, you can dilate it, you can rotate it, you can translate it. So these are the most basic functions that you have here. Okay, so there's your first one. It's linear. Your second one is y equals x squared, which I believe is right here. And so it is a parabola, and here is your table of values, and when you graph it, it looks like a parabola. Okay, then you have x cubed. I'm trying to find, is that right over there in red? So that is a cubic function. Yesterday when we talked about functions, we talked about for every degree you add a turn, right? If it's degree of 1, it goes in one direction. If it's a degree of 2, it goes up 1 and down 2. That makes a parabola. Okay. If it's a degree of 3, it's going to go up 1. It kind of flattens out 2. That is a direction change. And then it gets steeper and goes back on up 3. Okay, so that would be 1, 2, 3. So that would be a cubic function. And then if you look at 4, did I get 4? Is this 4? These are absolute value graphs. Okay, what shape do they make? They make V's. What do you notice about like the first 4? What do you notice about the parent functions? Okay, like as far as what point do they all go through, the parent functions? They all go through the origin. Okay, now not all parent functions go through the origin. When we look at number 6, that's not going to go through the origin. But your basic degree of 1, degree of 2, degree of 3, your absolute value, the parent functions will go through the origin. And then from there, what will happen, like I said, is when you start adding stuff to it or multiplying it with other numbers, then that's going to change it. It's going to move it. It's going to shift it up, down, right, left. It's going to vertically stretch it or compress it, or it probably possibly could reflect it as well. Okay. Number 5 is right here on the board. And so we talked about why you couldn't get the negatives, because if you take the square root of a negative, it's going to be imaginary. And that's why it says error in that direction, because it's not going to be on the negative side of the graph. Now, what's the opposite of taking a square root? Squaring. What shape is a squared equation? A parabola. So when it takes the square root, you know what happens to it? It just takes it and turns it sideways. Okay? And everybody says, but I don't see the other side of it. And that's what Matthew and I were talking about is we did the positive square root of x. That's what you're looking at right now is just the positive. If you want to see the other side of it, then you got to do the negative square root of x, which would give you the bottom half of it. Does that make sense? And put a negative because of the whole plus or minus. Okay? Now you didn't have to do that, but just so you know that it's a parabola turned sideways. For example, like if we have a cube root functions, cubes look like this. So that would be an x cubed. So what would a cube root function look like if it was turned sideways? It's going to go like that. It's going to make it turn on its belly. Does that make sense? Okay. And then the last one, do I have number 6 back there? Yes, number 6 is back here in the back. It is an exponential function, and you can see that's our penny trick. It started out really slow, but then eventually it skyrocketed, right? And so there's your exponential function as well. Any questions on that? The most basic exponential function will travel through the point 0, 1. It won't go through the origin, but the most basic parent functions. Any questions about these are parent functions? There are other parent functions, and tomorrow I'm going to give you a little page. I've got it over there ready to go that has all the parent functions on it. We call those parents because you start with those. From there, then you add all the numbers that go with the equations, and it makes it move. Okay, so that's what we're going to get into next. So here's what we're going to do next. So example 7. We are going to use the parent function and graph the following equations and compare and contrast to the parent function. So step number 1, I want you to graph y equals x squared. That is the parent function. It is the most basic form of a quadratic function. Okay, there's no numbers with it. There's nothing being added to it. There's nothing being multiplied to it. It's just simply y equals x squared. That is your parent function. From there, I want you to graph these equations, and we're going to see what happens when you add 3 or when you subtract 3. And does it make a difference if you are adding 3 on the outside of the parentheses with a square, or if you're adding 3 on the inside? Do you think it will make a difference? Yes or no? Yes, it will make a difference. So I want you to see what the difference is being made, and then tell me what happened to the graph. Okay? Now here's how I'd like you to do this. On this particular graph, I want you to graph the parent function. I want you to graph y equals x squared. And then I also want you to graph y equals x squared plus 3. On the second one, I want you to graph y equals x squared. Because I want you, so on each graph, how many lines will you have? Or curves, in this case? 2. You'll have the parent function, and then you'll have the transformation. Okay? All right, I'll give you about 5 or 10 minutes to work on. So let's go ahead and talk about number 7. So the first part, okay, I'm trying to think. Let's see, here's number 1 right here. So you have the parent function, okay? I need you to compare it to the parent function. So you start with the parent function that crosses the vertexes at the origin. What happens when you add 3 on the end of it? It moves up. Does it get bigger? Does it flip? No, it simply just slides up. That's called a translation, okay? If we have y equals the quantity of x minus 3 quantity squared, is this number 2? What happens? Here's the parent function. What happens to it? It slides over how many? 3. It slides over 3. Now, does this one make sense to us? If it's subtracting 3 on the inside, which way would we think that it would slide? We would think that it would slide left, but it actually slides to the right. Okay, so the left and the right are going to be backwards than what you think. The up and the down are going to make sense. Okay, if it's plus 3, we go up 3. If it's minus 3, we go down 3 on the end of it. But if it's inside the parentheses, that's going to make it shift left or right, but it's going to go opposite from what you think. If it says minus 3 on the inside, then that technically means it's going to shift to the right 3. Okay? Number 3, there's number 3 right there in red. What does it do? It's got a plus 3 on the inside of the parentheses, so what happens to it? It makes it shift to the left 3. And then number 4, where's number 4 at? Right there. So we have the parent function. What happens to when we subtract 3 at the end of it? It moves down 3. Any questions on what makes it move up, down, right, or left? All right, let's do one more. It's the last example for today. So this time I want you to graph the parent function y equals the absolute value of x. So what shape will it be? It's going to be V. And so I want you to take each one of those and I want you to graph them and tell me what happens to it. So here we go. Let's talk about this. The absolute value of x plus 5, what happens to it? If it's plus 5 on the outside, it's going to shift up 5. What if it were on the inside? What if it was like the absolute value of x plus 5 and all of it was on the inside? Which way would it shift? Left. If it's on the inside, it's going to go left or right. Does that make sense? And if it says plus 5, it's going to go opposite from what you think, so it'll go left. Okay. We just talked about this. When you times by a number that is less than 1, check this visual out with my rubber band. So here's your function. When you times by something that is less than 1, what happens to it? It's going to compress. So I'm going to compress this. What happens to it? It gets wider or fatter. Okay? If you times by a number that is greater than 1, so like the third one, the 5, what's going to happen to it? It's going to vertically stretch it. Does that make sense? So if it's greater than 1, it's going to vertically stretch it. If it's less than 1, it's going to vertically compress. Okay? It's going to make it fatter or wider. Okay? What about if it's a negative absolute value of x? It's going to reflect. It's going to flip. So it's going to make an upside down V, which is what I call a TP. Okay? Any questions on the reflections, the rotations, the dilations? All right, last thing that I'm going to leave you with is just a helpful chart that tells you what happens. Okay? I would. I'll put it up tomorrow in case you don't finish it. But it's a helpful chart that will help you know what to do. Okay? If it adds on the outside of the parentheses, it moves it up. If it subtracts on the outside of the parentheses, it moves it down. If it adds on the inside of the parentheses, it moves it left. If it subtracts on the inside of the parentheses, it moves it right. When the parent function is multiplied by -1, a negative is going to make it flip over the y-axis. If it's multiplied by a number greater than 1, it's going to stretch it vertically, aka skinny. If it's multiplied by a number less than 1, the graph will be compressed vertically or make it wide.